In this video, we're going to take a look at an example where we are going to calculate some probabilities for normal distributions, and we're going to do that using StatDisk. And so if we do that using StatDisk, we're going to go through these steps. The first is we're going to calculate a z-score. We will then, in StatDisk, make those selections, choose analysis, probability distributions, and then the normal distribution. We will then input that z-score and evaluate. It will spit back all kinds of information, and we will just identify the information that we want. If we want the probability that it's between two values, we're going to have to convert both of those values to z-scores separately, and then we will find the area to the right of both of those, or to the left. I wrote to the right here. Actually, in practice, I usually use to the left. Take the difference between the two areas. So let's look at our example. A bone mineral density test. It can be used to find the likelihood of developing osteoporosis. The results of the bone density test are normally distributed. So how do we know it's a normal distribution? Because in the problem it says it is normally distributed. So it's normally distributed, has a mean of 0 and a standard deviation of 1. So that tells us that we have a normal distribution, but more than that, we have a standard normal distribution. Right, so we know here the mean is 0. We know the standard deviation sigma, that is equal to 1. So we are going to find the probability that a randomly selected person has a bone density that is less than negative 2.21. Is this unusually low? Why or why not? And then we'll answer some other questions. So let's first find the probability that the bone density is less than negative 2.21. So let's graph it. We know right there in the middle for our density curve, the mean is in the middle. Our mean is 0 here. We think about this x-axis, this horizontal axis. We think about that being like a number line. And so if this number right here is 0, we want to identify where negative 2.21 is. And that would be to the left of this. So negative 2.21 is somewhere over here. And we want to find what is the probability that it is less than negative 2.21. So we want the area under the curve to the left that is less than negative 2.21. So we have that down. We need to take this data value. That's our data value. X is negative 2.21. We know the mean is 0 and the standard deviation is 1. And we want to use StatDisk, but we are going to first convert this data value to a z-score. And so our z-score is x minus the mean over the standard deviation. So negative 2.21 minus 0 over 1, which is just negative 2.21. Right. So on all of these, our z-scores are going to be equal to the data value right now, but that's because we have a standard normal distribution. If our distribution has a mean that is anything other than 0 or a standard deviation anything other than 1, those things would, the data value and the z-score in general would not be the same thing. So now we're going to take this z-score and we are going to go to StatDisk with that. So let's go to StatDisk. So statdisk.org. We are going to choose analysis, probability distributions, and we are dealing with a normal distribution right there at the top. Over here on the left-hand side, it says enter one value, then click evaluate to find the other value. So either a z-value or a cumulative area. We have a z-value. We are trying to find an area because we're trying to find a probability. So negative 2.21. It was our z-score. We'll click evaluate. And then over here, it spits out all kinds of information. So here is the z-value that we just entered in. That is the probability density. So that happens to be the height of the curve. at our z-value, but we don't really care about that. We care about the area to the left here because we shaded the area to the left. So 0.01355, that is our probability. So the probability that our data value is less than negative 2.21 is 0.01355. Then the question is asked, is this unusually low? And we would say, yes, it's unusually low. Why? Well, yes, it's unusually low because that probability that we just found is less than 5%. And so the probability of a bone density of negative 2.21 or smaller happens only a little over 1% of the time. And if it's anything less than 5%, then we say that's an unusually low value. So let's look at a second problem, second question. Here we want to find what's the probability our value is greater than positive 2.34. So our mean, still 0. Somewhere up here is 2.34. We want the area to the right of that. So we're going to convert that data value of 2.34 with a mean of 0 and a standard deviation of 1. Convert it to a z-value. So our z-value is x minus the mean over standard deviation. So for us, 2.34 minus 0 over 1. So 2.34 is our data value. We find the probability is our z-value. We're going to find the probability that our data value is larger than 2.34. We're going to take the 2.34, we're going to throw that into StatDisk. So again, in StatDisk, we're right here, but let me go through those steps again. We would choose analysis, probability distributions, normal distribution. I'm going to enter the z-value, 2.31, and evaluate. This time, the area to the left is not the value we want because we shaded the area to the right. So 0.01044 is the area that we want. That is the probability that is more than 2.31. So 0.01044. Oh, it was actually 2.34. Let me go back. Our z-value, 2.34. Evaluate that. Our area to the right is 0.00964. Is this unusually high? Again, the answer is yes. The probability that we calculated, 0.00964, that is smaller than 0.05. So that is an unusually high bone density of 2.34. All right, so this final one, we want to find what is the probability that the bone density is between 0.89 and 2.72. So somewhere up here is 0.89. Somewhere further is 2.72. We want to find the area between those two values. So what we'll first do is we'll calculate a z-score for 2.72, which is the data value, 2.72, minus the mean of 0 over the standard deviation of 1. So we get a z-score of 2.72. We will also do the same for 0.89, so the z-score that's associated with 0.89 is 0.89 minus the mean of 0 over a standard deviation of 1, which is 0.89. So we convert both of these to z-values, and then we are going to find the area to the left or the area to the right, it doesn't actually matter, the area to the left of each one of those values, and then take the difference. We will never, ever, ever subtract two z-scores from each other when we are trying to do this. If we took 2.72 minus 0.89 and found an area associated with that, that would not tell us anything meaningful. So we'll find the area associated with this. So the area to the left of 2.72 area to the left is 0.99674. The area to the left of 0.89. The area to the left of that is 0.81327. With these two areas, we are now just going to take the difference between them. 0.99674, take the larger one, subtract from it the smaller one. If you take that difference, we are going to get 0.43. So 0.18347. That would be our probability. That is the area under the curve between these two values. What we found was we found all of the area to the left of 2.72. And then after we found all of that area, we deleted the area to the left of 0.89. We subtracted that, and that left us with just the area between the two. In the next video, we're going to look at, starting with probabilities, how do we go backwards and find a data value. All right, we'll see you there.